Hello students, and welcome to this lesson on quadrilaterals in the coordinate plane. Our objective today is that we will apply distance formula and slope to prove quadrilaterals in a coordinate plane using journal notes and examples. So when we're talking about quadrilaterals and proving them, we're talking about proving that these are different types of quadrilaterals, right? And that's what our cutout is all about today. These are all of the different ways that we can show that a quadrilateral is going to be specifically a parallelogram, a rhombus, a rectangle, a square, etc., etc. So we're going to see the conditions that we already know about quadrilaterals expressed in a coordinate plane. And remember, a coordinate plane is going to be something where you can work in algebra, right? So you have like an x and a y, and then you can graph points. And we're going to use that to be able to prove that certain objects are maybe a parallelogram or something like that. So these are each a different set of requirements to be that figure in a coordinate plane. So for instance, if I want to prove that something is parallel, I need to show that both pairs of sides are parallel, and I need to show that both pairs of sides are congruent. So remember, these conditions would be met when I have both pairs of sides being congruent and parallel. So at base, this seems pretty simple. However, when we're working in the coordinate plane, there are specific things that mean that something is parallel, right? We know that two equations are going to be parallel if their slopes are the same. So that's going to be the key thing here, is looking at the slope. Then when we're talking about congruency, we're talking about the distance between points. So to prove that something is a parallelogram, we're going to have to utilize both our slope formula and our distance formula. Now let's also talk about our quadrilaterals being a rhombus, right? Then we have to show that all four sides are congruent. And again, congruency means that we're going to have to use our distance formula, because that is going to be saying that they have the same length, and we know that length is kind of related to the distance between 2 points, as we've seen from our formula where we used our Pythagorean theorem earlier. All right, then we want to prove that a quadrilateral is a rectangle. So we're going to have to show that it's a parallelogram. We already know that. Rectangles are all parallelograms. And then we need to show that all four angles are right angles. So to be able to show that, I need to show perpendicularity. We can also prove that something is a square. So first we have to show that it's a rhombus, and then we do that same thing. We have to show that this is going to be perpendicular. So to prove that something is a kite, we're going to have to show that it has two pairs of congruent consecutive sides, but not all four sides being congruent. So that's going to be, remember, something that looks like this, in reference to your properties of quadrilaterals as well when you're doing this exercise. Showing a trapezoid means that we're going to have one pair of parallel sides. The other side can't be parallel. So all four slopes need to be computed. So we're going to have to compute all the slopes to find out if a figure is a trapezoid or not. And then finally, we want to see whether or not it's an isosceles trapezoid. So first we show that it's a trapezoid, and then we also have to show congruence. So that's again going to be our distance formula. Alright, so let's take a look at some of these tools that we're going to need to be able to compute all of this. So for parallel lines, like we said, are going to be parallel if their slopes are equal. So if two lines are parallel, then their slopes are equal. And remember, your slope formula is m is equal to the rise over run which is equal to y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are points. Then finally, perpendicular lines. So we have actually gone through this last semester, but let's talk about that perpendicular condition. So if two lines are perpendicular, then their slopes are opposite reciprocals. And let's remember what opposite reciprocal means. First off, opposite is talking about the sign. So it's going to be the negative, and then the reciprocal is going to be flipped. So we make it negative and we flip it. So if we have a slope of 7 over 2, then the opposite reciprocal will be negative 2 over 7. So that's what our opposite reciprocal is we take our initial slope and we make it negative, and then we flip the fraction. That's what the reciprocal is you flip a fraction. Alright, and now let's talk about congruent line segments. So if two line segments are congruent, then their lengths are equal. So how do we know if their lengths are equal? Well, we can use the distance formula, right? So you use your distance formula. And that distance formula is going to be, some of you might remember this, but d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, this is really just a result of Pythagorean theorem. So if you forget this, use Pythagorean theorem. There's really no difference between this and the Pythagorean theorem applied onto a coordinate plane. So I want to do a quick proof real quick as part of our notes, and then we're going to go ahead and go into our examples. Alright, so we're given the points negative 6, 3, negative 2, 0, negative 2, negative 5, and negative 6, negative 2. And we need to actually put these into a coordinate plane and classify the quadrilateral which occurred. So let's go ahead and throw it in a coordinate plane and just see what happens. So negative 6, negative 3, negative 6, positive 3. So that's going to be 1, 2, 3, 4, 5, 6, 1, 2, 3. Alright, so we have a point here, and that's point A. And then we have point B, which is at negative 2, 0. Negative 2, 0. That's point B. Then you have point C, which is at negative 2, negative 5. 2, 3, 4, 5. And then you have point D, which is going to be at negative 6, negative 2. So 1, 2, 3, 4, 5, 6, down 2. Alright, so that's C. And that's D. And whenever you get points like this, you're going to connect them according to the order. So you would go from A to B to C to D, and then D will connect back to A. So just at a glance, it looks like this might be a rhombus, potentially. I'm not sure yet, so we're going to have to do our classification and find out. It's obviously going to be a quadrilateral of some type, and right off the bat, because I have this segment here, AD, I can already tell that AD is parallel to BC, because the slopes for each of those is going to be that it's going to be the lines here. So you don't really have to worry about calculating those slopes. So we already know those slopes, and it's not going to bother us at all. So I already know that those two are parallel right off the bat. These other two look like they are probably parallel, but we need to actually analyze them to be able to determine that. So right off the bat, I know that those two are parallel. So I know that at least this is going to be either a trapezoid or a parallelogram. All right, so now let's analyze AB and DC. So if we look at AB, it looks like my slope from A to B is going to be right 4, 1, 2, 3, 4, and down 3. So we do rise over run, so it's going to be the slope, so the slope of AB is equal to rise over run. So it's going to fall, actually, -3 over the run is 4. So that's our slope. So now I want to compare that slope to the slope of DC. So we can say that the slope, well, let's take a look. It looks like it is also going to run 1, 2, 3, 4 and fall 3. So we also see that the slope of DC is going to be -3 over 4. So now I can say that AB is parallel to DC. And now the important thing is going to be that we figure out if all of these segments are congruent. So that's going to be the hard part. So let's go ahead and analyze that. So I know that the length of AD is equal to 1, 2, 3, 4, 5. So I can actually just count from A to D. That's going to be 5. And then I can also see that that's the same thing for BC. So I know that AD is congruent to BC. All right, so it looks like we're at least working on a parallelogram, right? So I'm going to go ahead and assume that DC is congruent to AB because I already know that it meets the condition of these two lines being parallel. Therefore, I don't really need to calculate any further there. I know that they must be congruent because both of these pairs of sides up here, it's already a parallelogram. So really, I'm just trying to determine if this is a rhombus or if it is just a general parallelogram at this point. So I need to check and see if AD is congruent to AB. So that's my next question is AD going to be congruent to AB? So we need to find the length of AB, and what I see is that we moved 4 and 3. So I formed this triangle here of 1, 2, 3, 4 in length by 3, and I'm looking for the hypotenuse. So this is 4, this is 3, and I know that 4 squared plus 3 squared is equal to 16 plus 9, and that's going to be equal to 25, and that's equal to x squared. So I know that x squared equals 25, therefore x is equal to 5. And so the length of AB is equal to 5. So now I know that AB is congruent to AD because I already knew that AD was length 5. So now I've determined that not only is it a parallelogram, it's also a rhombus. So that's kind of what we're doing here. My suggestion is to always graph the points first and kind of see where the problem is heading, right? Just like I said earlier, it looked to me like this was a rhombus, so I kind of started to ask the questions that would lead me to it being a rhombus. So I was trying to prove or disprove if it was a rhombus, and to do so, I was asking questions thinking in the terms of, well, maybe it's a rhombus. All right, so go ahead and apply this type of thought here to your examples. So your examples are going to be your in-class assignment today. So you want to complete the examples using your list of how to prove. Really lean on this list here that you have, right? You have all of the requirements that you have to meet to make a certain figure. So make sure that you're using those. And finally, your reflection will be completed at the end of class. So look at the board near the end of class for your reflection. If you have any questions, let me know. Have a wonderful day. Goodbye.